sure I'll look on it in horror later.
Was the last one that bad?
Thanks for coming, everybody. This is graphs in action, and no, that doesn't mean graphs in action, one word. It's just, it's graphs in use. I'm Nathan Freeman. I'm with Red Pill Now. And if you've been around some of these conferences or you've seen some of my exhortations on the web, you know that I'm becoming a huge fan of graph database technology. And I'm going to talk to you today a little bit about what graph is and then how it relates to Notes and how you can use it in Notes and Domino. And I want to point out to you something very important. Everything you are going to see today is free and open source. 100%. Okay. All right, so I want to accomplish three things. We want to challenge the way you think about Notes. We want to change the way you approach your next project. And we want to bring you faster and better results with your own data, with the data you've already got today. That's our objectives. So first, a little intro. What's a graph database? It's a data set that has what are called vertices and edges. And vertices really represent your entities and your concepts. So if you have a graph database of movies, then if you had IMDb as a graph, you would have each movie title would be a vertex, and each actor would be a vertex, and each character would be a vertex. And then there would be edges in between them saying, well, this actor appeared in this movie, and he portrayed this character. Make sense? Mm-hmm. Oh, one other thing, by the way. This is absolutely an interactive presentation. If I get too ridiculously technical or if I go too fast, I get very excited about this stuff. Like, this is my life. So I'm really, really excited, and sometimes I just talk about it too much. If you want me to slow down, don't hesitate to shout out, throw things. You can use a blow dart if you want, but whatever you need to do. If I'm going too fast or if I'm going over anybody's head, please slow me down and stop me and help me keep you engaged. So an edge in a graph has two things about it, in and out. And that's just saying, here's my in vertex, and here's my out vertex. So they're always directional, but you can traverse the edge in either direction. Okay? So who uses graphs? You might recognize a few of these names: Facebook, Google, Microsoft. Everybody else except IBM, who's a virtual ISP. And I'm a little facetious there. It's my understanding that the Titan graph database is being added to Bluemix. It's in a pilot section. It's actually called Titan for Watson. So I guess in theory it's going to be the Watson team that's going to be using graphs, which, hopefully as we go, you'll see makes a ton of sense. So let's take a simple example of a graph. We might have a purchase order. This is the kind of data that a lot of people in this room have probably dealt with before. And it would have a property of a PO number. And we might have another vertex in our graph called a product, and it has a name and a description. The purchase order includes the product on that order. So there would be an edge between the purchase order and the product that would indicate, have a label called includes. The in would be the purchase order, the out would be the product, and the edge is where we'd have our unit price, quantity, and subtotal. Right? So the edge itself has properties. This is the key thing to understand about how graphs work, is the relationships themselves. They're discrete records, and they have properties. It's not like a relational database where you get the result of the joins, but you only know the things about the rows themselves. In this case, the actual relationship itself can have individual properties on it. So another example, if we had, say, a contact directory, we might have Red Pill Now as a vertex. They have an address, URL, SIC code. Nathan Freeman might be a contact list as another vertex. Again, attributes of phone, email, Twitter handle. And then the edge would indicate the relationship between Nathan and Red Pill Now, saying I work there. And that might have start date, title, and department. Because those are attributes of the relationship, right? They're not attributes of me. My title isn't me. My title is an attribute of the fact that I work at Red Pill, right? So you can imagine, you think about it, like every place you've ever done a contact list before, you made title and department a property on the actual contact. Now let me give you a better example of why that's a problem. What if we had OpenNTF as another company in the same graph. Well, so now you have Vertex Nathan Freeman. I have 3 different kinds of relationships, right? And they all mean different things. So I, co-founded OpenNTF. By the way, this just says founded, not co-founded, because there would be multiple founded edges coming out of OpenNTF. One would go to Bruce, and one would go to Vince, and one would go to me. I'm a contributor there, and I work there as with the title of director, right? Because I'm on the board of directors. So you can see how now using a graph approach and thinking about this in a different way, we can get much more robust information about who this contact is. If you went to your typical CRM and tried to do this, you'd have 3 different, and including Red Pill, you'd have 4 different Nathan Freemans, all describing different attributes of the relationship. Does that make sense to everybody so far?
It makes total sense, particularly in light of the fact that my iPhone with my multiple traveler accounts, I've got like 4 Nathan Freemans.
Yeah.
On my phone.
Well, there are 4 Nathan Freemans in your phone, by the way.
Yeah, but I mean, they're all the same guy with the same exact information,
Google does
but they
that
just
too.
came out of different systems. It's like, maddens me.
You can link them, but it takes tapping.
I can't link them. I can't work an iPhone to save my life. I had to hand it to him yesterday.
It's this whole touching the screen thing. You just Devin can't do touching.
Where's your flip phone?
Back at the house, man.
Back on the enterprise.
Raymond Reddington, you still on the flip phone?
I miss my Nokia.
So how do graphs relate to NSFs? So all of the stuff that I'm talking about here is implemented in the OpenNTF Domino API. If you don't know what that is, Google. Come on. But it's the ODA for short. But it's a great OpenNTF project with a world-class team building amazing things in Java, and I'm just like one small part of it that is trying to avoid having to get involved with Maven. So some of you may have heard me talk a little bit about this at the last MW Lug. Peter and I did a session where we talked about graphs. And we talked about the current state of them then, and I mentioned someday we hope to have a graph that works like this. Well, now that thing exists. So the graph engine that's in the ODA now, any NSF that you have, any existing application can be added to the graph. You can just go, over here's my customer.nsf, over here's my expenses.nsf, over here is travelrec.nsf. I'm going to make a graph, and all those things just get included together. Okay?
So, sorry.
No, please.
Is a graph a thing, or is a graph a concept of how to think about how these relationships are?
So the graph is it is a concept of how to think about them, but it's an API that's implemented to allow you to work it as a thing.
Okay.
Right. So I can show you a code example later. I hadn't intended to show this particular code example, but I'm happy to, of how you initialize one. Because basically you got a Domino server and you say, I'm going to make a graph, I'm going to call it this. I'll call it, the one I'll use is called now. So I made a graph that's called now, include that NSF, that NSF, that NSF, and that NSF. And by the way, they could be on different servers. Any document can be a vertex in the NSF graph engine, right? So if you have an existing customer, that customer simply becomes a vertex in that graph. And now, and this is very new, I only started on this last week, any view in any NSF can be a vertex, and then the view entries then become edges. So if you think about it, we've actually worked with this concept for a long, long time. We didn't have a starting point in the vertex, but the idea of having, well, here's a thing that has its own properties that has a way that relates to a thing that has a lot more properties, some of which might even be different. Because you have a view entry, and it has column values, and you say get document, and then you have a document, it has a bunch of different stuff, right? So now, you could say, well, the view itself, the design note for the view is actually a vertex, and you can use the graph API to traverse the view entries in it as if they were edges. Right? So it wraps that concept up so that you can just treat them like you do with anything else that's in the graph. Cool thing about this is, if it's a hierarchical view, and you've got categories, when you say view get content or get edges contents, you get the first level categories. And each of those categories then becomes a vertex. And you can traverse to that vertex and then say, now, you get edges, contents, and get the next level. So you can traverse a view navigator instead of having to work with it as like a big hierarchical beast. I was very excited to be able to get that code done. It's not perfectly stable yet, but it's starting to come together, and it's really cool. So I'm very excited about it. So if we're going to talk about graphs, we also have to talk about frames. So frames are they're part of a specification called TinkerPop. TinkerPop is the open source equivalent of JDBC for graphs. It is a specification that graph database creators meet, and it is a way for Java developers to interact with any existing graph database. So you don't have to know what the backend is. You write your code to TinkerPop, and it just works, with whether you're using Orient, or you're using Neo4j, or you're using Titan, or you're using Domino. So part of that spec is called frames, and frames are just a really super easy way to define specific Java objects that are serialized to the graph. Okay? So you define Java objects by creating just annotated interfaces. I keep tripping on this thing, by the way. I just don't want you guys to think I'm some kind of idiot. It juts out here. And so you just build interfaces with annotation, and you can do, it's totally optional whether you write any Java code to implement them. All right? So let me show you what one of these might look like. If my mouse works. And the fun part about them being interfaces is that they become very, very extensible. So when I was in, when did I go to Dan Notes? Do you remember? That was like last October, November? It was the first time I was presenting the graph stuff to any user group. And I had this idea on the plane on the way over. I was like, graphs would be like a really great way to do social. Right? Because that's how Facebook does it. So somebody puts a post on Facebook, and then people come along and they go, I like this, I like this, I like this. Well, the post itself is a vertex, and all the other users on Facebook are also, they have vertices, and when you hit like, it creates an edge, indicating that you like the thing. Right? So I was like, well, that should be easy to do here. So I created an interface called Likeable. Right? So anything that I want to be able to like, I can assign it to Likeable, or I can extend Likeable. And then I can find out, well, get who it's liked by, find a particular liked by, remove a like if somebody wants to unlike it. And I can go to the edges themselves, or I can go all the way across to the other vertex. Right? So the like itself actually has attributes. Now it gets a little more interesting. Sorry, I should have had this open already. See the guts of the thing here. So a rateable is something you can apply a star rating to, right? And so the relationship itself, called rates, so you say that this person can rate things, this thing can be rated, and once you've established that, then whenever you want to have somebody rate that thing, you're just adding one of these rates relationships to it, and you'll notice that's where you put the rating itself, on the relationship. Right? Wouldn't make any sense to put it on the thing that you rated, because you want to have a whole bunch of them, right? And you don't want to put it on the person, because the person might rate a whole bunch of things. So naturally, the place for the attribute, the particular property to go is on the relationship. Does that make sense? So I made a whole social graph that included comments, likes, ratings, and shares, and it was about 2 hours on the plane. And that was it, and it just works. So if you'd like to know whether you can be productive with this stuff, yeah, it does really well to be productive. We had I forget what was, we were working on a session with Paul Withers, and he's using the social part of this graph for one of the demos that he's been building. And he said, it would be really nice if we had a way to tag mentions of other users. I was like, oh, well, that sounds like another good relationship. Let's put that in. So I added it. It was 15 minutes, I think, from first remark to it's checked in. And it shouldn't be a surprise. it's not exactly complicated. Right? It was only 15 minutes because sometimes I'm slow typing because I was in a Skype chat. Right? And now it's very easy for him to just watch for any string that's added, or you put an @ with somebody else's name. When he sees the string, he's interrogating a REST service to get the list of users. He sees a string added. He says, "Okay, let's add one of these mentions relationships in there." Everybody still following?
Yep.
Okay. Yay! I'm on point. So we did the likable, liker. That's liker, not liquor. Although it's almost 5, or it is 5, so we should be thinking about liquor. So
I don't even know her.
I knew that was coming. I could see the neurons firing. So this is actually a little example of part of what Red Pill's forensics technology does with graphs. So we have a vertex called a replica, and it extends likable, so you can like applications, right? That makes sense. So, yeah, I love this app. Oh, I hate this app. Yeah, don't put it on. It should probably also extend rateable. That would be a lot more revealing. But one. And obviously replica ID and title. We have another vertex called database that has server and file path, and then there's a relationship between a database and a replica indicating that that database is an instance of the particular replica. Right? We have another type of vertex called a view, has properties like whether it's a calendar, and then there's a relationship between the view and the replica indicating that this view is defined in this replica, right? That's where the view design node is, so you know it's in all instances. But the view index information is specific to the database because it may be in one database but not in another. You have multiple replicas and views indexed here, but it's not indexed over there. This gets particularly handy when you decide what you want to show to a user in a portal. If they ask for the index and you know it's not built here, but it is built over there, then go to the place where it's already built.
Rather than rebuild it.
Rather than build an index that doesn't exist yet, because then they have to wait for it, and they don't like that. Still make sense to everybody?
Mm-hmm.
Okay, cool. So, how do frames and NSFs relate? Any NSF, since any NSF documents can become vertexes, any NSF can hold frames. And we use the form item to determine the frame via an annotation called type value. So in that replica vertex I was just mentioning, there's a little annotation at the top that says the type value is replica. That means that when I create one of these vertices and I save it into the NSF, the form is going to be replica. Now you might go, well, what difference does that make, Nathan? Because, you know, do you have like a UI for the replica? No, there's no actual form there. But the form name is used to identify the type of object that it is, because in this case it's brand new data. But what if you already had context.nsf and had a bunch of person documents in it? And you could just go here and say type value person, and then write a Java object model for your person documents in the database, and everything you already have now has an API built for it automatically. So you're just creating an interface like this, and by specifying the name of the form there, you automatically get a Java API with whatever rules you want to put added to the interface for your existing applications. Everybody still following?
No. How do you get the Java API? You just lost me on that.
Okay, so here's an instance of this replica object.
Right.
Let me show you a place where I use it, and you can see what the use of the API is like. If I can remember where I put the demo code. Where is it? Where are you? No, this is my mouse not working correctly. Ah, touchscreen. Yes, very good.
Where's your flip phone?
Yes, yes. Where's my flip phone, but it's someplace else. I apologize for the delay here, guys.
I'm sorry.
No, it's a great question, and I need to answer it, and I just want to, because I recently moved this code around, and I don't remember exactly where I put it, and for all I know, it may not even be in here. So here is, here's an example of where I use it. So I have I've created a graph here, and I'm dealing with a database object, and I want to get this replica object for it. And don't get confused by the fact that it's a database. That's just what I'm analyzing. This could have been a person document, right? This could have been an expense report. So don't, just because I'm referencing replica, it's not that it has anything to do with that. So I get this replica, and then it already has an API where I could just say add instance and attach it to the database object that I got, and then I can set a title and set a replica ID and set a forensic state. Right?
And that creates the edge.
This line right here creates the edge.
Okay.
So this line creates the replica object. The replica ID is a key. So if it doesn't already exist, it creates it. If it already exists, it returns me the one that I've got. This key, by the way, gets hashed into a UNID. So whenever you're accessing it, there's no views involved. The key is instantaneous. This builds the relationship, and then this sets the properties on there. Okay, so I'm setting up, and the title, or let's do like the replica ID. So on the interface here, I've defined a property called replica ID, right? So there's my getter and there's my setter. This string here defines the field that's going to get stored in.
Got it.
On the
Okay, so
document.
that's where your API comes from.
Right.
All right.
And but you'll see there's no implementation, right? The setter
Right.
doesn't call any more code. That just happens. So you're defining a getter and setter that are empty, and you could do that for all the properties. Yes.
So if I have that contact form in person, and in my old notes database it has 70 fields on it, and I want to do this, I need to set 70 getters and setters up when I'm
You do today, until I can make a tool that will automatically read the form and build the interface for you, which I'll probably charge for, because that'll be super useful. So until there's that level of automation, yes, you have to sit down and write the interface itself. So I'm still writing these by hand myself.
Yeah.
But you're just saying, and really the other reason you have to do this, like you don't have to write the setter if you know it's read only.
Yeah.
Right? You only need to create the stuff that you actually want to do. If there's 70 fields, maybe you don't need to be able to control all 70 fields from the graph itself. And by the way, this is just for the frame object. When I get a replica that is defined as one of these Java objects, I can also say dot as vertex. And then I actually have the graph vertex object. And then I could just say get property and give it any old name I want. It's just a string. And that essentially gets passed to a get item value.
Mm-hmm.
It's not exactly what happens, but it's close. Actually, I shouldn't say it's close. It's just a shitload of code, but because it does type coercion all over the place. If you define this as returning, say, a map, the API will automatically convert whatever it finds in the field into a map for you.
Oh, nice.
So it's the return type is actually enforced by the underlying API. That was partially my doing and partially the Tinkerpunk guys. Still got you so far? Mm-hmm. Still good? Okay. Yay. Okay, yeah, this is so you're the first people that get to hear about this. At least I think. I've added a new plugin to the OpenNTF Domino API. That is a REST plugin. It's a DAS extension. It's an extension to the Domino Access Services. And it's going to be graph aware. It's not yet, but what it is frame aware. Because I service my needs first, then I needed frames before I needed graphs. So if you've defined a graph on your server and you load up, you make a plugin that just specifies that you want this graph to be available in REST, there it is. Okay? So what the hell does that look like? So first thing is you have the base route on your server to get to the service at all. So your server slash API, which just tells the Domino server that you're going to be going to a REST API. ODA, which is the specific REST area for the OpenNTF Domino API. And then, so far, there's 4 routes beyond that. Frames, to say you want to work with a collection of frames. Frame, to say you're looking for one particular frame. Command, which allows you to issue commands to it, almost like making agent calls. And schema, which says, I want you to tell me what this graph looks like. Right? So I can determine by looking at the resulting REST what the hell other calls I can make, and what data types I should expect, and that sort of thing. This will, at some point, include vertices, edges, vertex, edge, all the graphy side of things as additional routes. There's only so many hours in a day. Plus I live in Mexico now, so it starts a little later and tequila begins at 5. I'm just kidding, it doesn't really begin at 5. So then the next layer is the namespace. That's the namespace that you've given to your graph. Right, so in some of the demos we're going to look at, that'll be now. And then you can use parameters, right? So some of the base ones are, if you're dealing with one particular element in the graph, it's an ID. If you want to get a group of frames, it's a type. And if you want to issue a command, there's a command equals parameter. So let's look at some of those. Okay, this is the part where I have to use my finger to change tabs in Chrome. I have to be very careful. Don't accidentally close them. So here, I'm going to the frames route in the API. I'm going to my graph that's called now. So I've registered my graph on the server via a plugin, called it now. And I said, I want all type equals replica. And so here is the JSON results of all the vertexes for the replicas that exist on this server, because I told it to scan and create these vertexes. Still got you? Okay, so, and you'll see these. Can anybody figure out what that ID is? Somebody who I haven't already told. sorry, Jesse.
What's the replica?
Looks like a document unit.
This one here, you're both right. It is the replica ID plus the UNID. In the ODA, that's called the metaversal ID. Because the universal ID is not, in fact, universal, because it's only within the domain of that one data silo of that replica. So you could have the same universal ID across many replicas, which means it's not universal at all. So that's the metaversal ID. That is a unique ID within your domain. You could have duplicate IDs across multiple Domino domains. Probably do it on purpose if you really wanted to. So that's all everywhere the graph uses IDs to identify documents, that's what it uses. And that's why the IDs can span across multiple databases and even across multiple servers. Okay. So if we zoom in on one particular one, and I think the one I pre-chose was the administration requests. So this time I'm using the frame route, and I'm giving it the ID in the URL. And by the way, this is just how I happen to choose to implement this. If anybody wants to tell me or suggest implementing it differently, like what if I could do a post or with the ID as part of the post, or what if it could be an extended header in the request, I'm open to ideas. This just happens to be how I implemented it so far. So I've asked for the properties of this vertex. So you see we're just getting back to 1. And I added an extra switch to the end that said end edges. And now that gets me the edges coming off this replica. But obviously we're not seeing all the individual edges. It's telling me the type of edges that it has that have been defined for it and how many of those there are. So I can know in advance what's worth traversing to.
So Nathan, why not, maybe I'm just stepping in very late here, so
So why not make the ID part of the path in the URL?
I thought about that, and that is the way DDS does it, which was a great argument to not do it. No.
That's more REST-like, that's why.
You think it's more REST-like?
Yes. Some people like graph brands. I do.
Again, I'm open to ideas. If we can make a compelling case for it to work that way, and I don't mind. It's easy enough to change. I think there was one reason that I wanted to do it, because I wanted to allow you to request multiple IDs at once. Right. So you could do $ID equals da da da, and ID equals and another ID, and they'll both come back. I would demonstrate that if Chrome was not so flaky that I'm afraid it's going to crash on me. But when I get a mouse or my machine's working right, I will be happy to show that to you. But you can actually do multiple IDs.
I guess the argument would be include the ID in the post body, or a list of an array of IDs,
Yeah.
and a JSON object that you post.
Right. I am trying to make sure that there's as much as possible without having to do post. Just because everybody hates post. Everybody hates post. So now I'm making a slightly different request. I'm saying I want to get that ID, and I want all the edges who have a label called found in, right? Because we just saw found in, it said there were 61 edges. So now I said label equals found in, and now it's come back. I am going to fall on my face, I swear. So now it's coming back with all of the edges, right? So remember, this is the relationship definition, right? This is telling me, so it's saying, I found an edge between, in the in is this replica, and the out is a design element of some kind. Because that's how it's been defined, right? And it's got created and modified dates on it as well. Still got you? Okay. So here's the next fun bit. So you might say, well, I don't really care about the values on the edges. That's not what I'm looking for. I want a list of all the design elements in the admin request database. Right? Show me what the other vertex at the other end is. Okay, no problem. We add another switch over here. It says, you can't quite see it. It says and vertices. And now, what's come back is not the edge, but the vertex at the other end of the edge. Still make sense?
Yep.
So you can pick which one you want. And you'll see some of the reforms if I scroll down far enough, because I scan the forms first so they show up first. There's views. Right, and you'll see there's different properties on the views because there's a different model for the view. Okay, so a little bit about some of those switches. So we talked about edges, labels. If I only wanted a subset of the properties off of the vertexes that I got back, I can say and props and give it a list of property names that I want back, comma separated. Or you can do and props multiple times.
Oh, okay.
If I'm getting edges, then I can differentiate what properties I want about the in and the out vertexes in the edge. Right, so I could say, oh, when I do this one, if I included an out props called title, then it would go ahead and follow this edge and get the title for that particular design element included as another attribute of the JSON. I wonder if I can tempt fate and show that.
Fingers crossed.
Yeah. So see, now it's come back with the title. Hey, this is all about scratching our own itch, by the way. We need all these features in order to do what we do at Red Pill, where we're building the portal that links into this entire graph. So and with what we do, we build a graph like this that's got every single one of your nodes databases. Right? And you're looking at all of it through this REST API. So we talked about that you can use the vertices switch. And then other fun stuff you can do whenever you're dealing with a list. So you can apply one or more filter key and filter value pairs. And you can say, I only want to get stuff with it where this key has this value. Right now, it's only an exact case matching value. There's not like partials or anything like that. Haven't gotten to that yet. Keith is all over me about that, though, so I have to do it soon. Order by, so you can reorder the list by whatever property you'd like to sort by. Again, you could put in multiple properties. Start and count, that's just so you can break through the list if you want to do paging on it. So start at 1 and go to 10, and then start at 11 and go 10 more and whatever.
If you sort by, if you're doing an order by sort, can you pick ascending or descending, or can you?
Not yet.
Okay.
But I'm sure I'll have to do that eventually.
Okay.
I think reversing the order of the resulting JSON array is something that wouldn't be very hard on the JavaScript side, on the client side. I want the server to do the sorting because that could be a very I/O intensive job. And if you're doing paging, you want the ordering to happen at the server so that when you're only getting the page, you're not making the client get the entirety of the data and then manage the page on its side.
Yeah.
Any questions? Okay, well, that's interesting because I think I'm done. So if you don't have any questions, we're gonna finish early.
Wow.
Nice. How does performance compare to the
How?
You need a trinket?
Yeah, I need a drink. It's after 5. Where's my cocktail? How is performance? As far as we can tell so far, it's very good. And here's the reason why. Now, I mentioned earlier that you can use a view as a vertex, and the view entries are treated as edges. They take you to whatever they point to as their out vertex. But the core graph engine itself, all the demos you just saw, there are no indexes involved. 0. Right? So because there's no indexes involved, you're not running the view indexer, you're not having to build those giant view attachments that end up getting embedded in the NSF, and you're not taking the performance hit for that. Right? NSFs themselves, if you don't put any views in them, and you're just accessing documents by ID, it's very fast. It's the absolute fastest way to get to a document, and I mean, that's already known and measured. The fastest way to get to a document is either node ID or UNID. I don't think anybody's ever been able to detect a difference in the performance speed between the two. But it's much, much faster than all the other vectors you use. And all the relationships themselves are defined as documents. So you don't have to go to a view. It's not like you're doing a get all entries by key in order to find out the relationship between that replica and the design elements that are in it. The replica has a listing of the edges of that particular type that are part of the replica document itself. And it follows those to the corresponding UNID addresses. And then it's only document access to get through there. So our experience with speed, and we built graphs based on this stuff that have, I think the largest we've done so far is like 2.4 million. And it's linear. I mean, you can't tell that you're dealing with a graph with that much data in it. And of course, now that we can do sharding, now that you have multiple NSFs, and you can say, well, over here, I'm going to put this kind of data, and over here I'll put this kind of data, and over here I'll put this kind of data. You have to cram much less into any one NSF. So if your graph is made of 100 different NSFs, then you have way better performance characteristics for them. Like you could say, well, I'm going to put all my edges in this NSF, and then I'm going to take that NSF and put it on an SSD drive and stick it local to the server. So that every place where I'm managing relationships is like the fastest thing, or maybe just make a RAM drive and put it on there. Right. More questions? Gotta have more questions. Or I did a really great job because everybody understood what the heck I was talking about.
I don't know if this is an offline question, but I'm looking for a use case.
You're looking for a use case.
Because this is a fun technology, but like, why should I use this as opposed to, why should I use a graph as opposed to?
As opposed to, why should you use a graph as opposed to doing DB lookups? Or why should you use a graph as opposed to using SQL Server?
Both.
Yes.
Okay, so I'll make the, back myself into that corner, didn't I? So why you should use graphs instead of using, like let's say you wanted to build a CRM, right? Everybody's reasonably familiar with this use case. I got a set of customers and prospective customers, and I've defined all those as organizations. I've got contact lists, I've got activities and opportunities, and emails. These are all different kinds of entities that I'm going to put in different places. Now, if you're building your first generation CRM, typically what happens is somebody says, I'm going to make an NSF, I'll make a form for each one of these things, and they're all in that NSF, right? And then they get a user. Get the first user. Now, OverQuota was multiple databases from day one. Sorry, Timothy pointed out to me earlier, asked me, did you work on this old product, this old Notespace product from like 2 decades ago? And it turned out I had.
I was looking at the Lotus script, and the header was like, Nathan from, oh, come on, I can't be two Nathans.
No, there are 4.
So the reason you want to use a graph instead of like your typical DB lookup, embedded view type of approach is that it's much more performant and it's much more scalable. Yeah. So the scalability is extremely linear. Another reason why you want to do it is the fact that the data is scattered across multiple NSFs is invisible to the higher level API. So you don't have to think about, where did I put that data? Because if you say, well, over here is my list of customers and I want to click on a button and show a list of contacts, well, you have to know where to go find those contacts. And that turns out that's actually kind of a pain, right? Because, you know, first off, the first year guy who's just started working with notes hard codes a server name into the DB lookup. And then the guy comes behind him and says, no, we can't hard code the server name, but he hard codes the path. And then the next guy comes along and says, no, we should do it by replica ID. And that works great in his dev version, and then you roll it out to production, and you find out your production systems are all looking to your test data in the dev system when you go to get a contact list. So hopefully that's a few of the reasons why I think this is better. Now, why shouldn't you just go put it in SQL Server? Again, the scaling is actually better in a graph. Now, I'm not going to say that the NSF graph will outperform Oracle. I'm not stupid. OrientDB and Neo4j will outperform Oracle. Those guys can do that sort of thing. Because when you get into higher order traversals, relational systems are very slow because they have to work with the entire data set, right? When you're doing a sequenced join in order to run a traversal like you might have on LinkedIn, let me find who are all the people who are 3 degrees separated from me. In a relational database, that query, LinkedIn actually did a test, and that query took like 4 hours to run on their system. And then they took all the data loaded into Neo4j, did the same request. It took 1.5 seconds. Right? So and personally, I think, especially once you get into frames, it is a much more natural API to code in. Right? Because you have a very simple way of building a model, and then the API that you're writing, if you're writing Java code, the API you're writing the Java code in is very easy. Contact add works at customer. And you can really get a lot of things down into sort of object, action, subject, and a lot of the code. So most of the code that I end up writing is very much of like, this object has this relationship, this action takes place to this subject. And you're adding or removing or getting the action itself. So I think it's a much simpler API. And if you look at like I realize this might feel a little overwhelming when you first glance at it, but unlike, like if you were using DDS and you were, because this is coming from documents, right? This is a document, 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 this is a document. So if you were just looking at this with DDS, you could get the same information out. The problem is that the JSON would be very heavy, right? Because it would give you field name information, and data type information, and it wouldn't be like a trimmed down model of what you had. And you'd be getting like every item that existed, even if it wasn't a germane part of your API, right? I don't need to know the dollar updated by field on this particular object. It's just not relevant. Did I answer your question?
Yes, thank you.
Okay, wonderful, thank you.
I would think another reason would be if you had data in a lot of nodes databases. My company does international development projects, not software development. They're like international aid stuff. And there are 15 years of nodes databases, one for each project, 70 projects running at a time, all designed by first and second year nodes developers. Forms slightly different, field is a little bit different. And if I want to put all that data into SQL in order to cross-project reporting on what's happened in the last 15 years, I need to spend 15 more years rationalizing that data, by which time they don't care. And so I'm thinking this might be a way to look at it, because I don't have to, I can ignore fields that are different in between the different databases if I want to. I couldn't let that data exist if I had to first put it into an SQL table.
We're actually, there's some level of discussion. Now, this is more of a red pill commercial aspect, not necessarily open source. But we're actually thinking of making this part mappable. The property that's being annotated here. So you'd actually be able to say, well, I want this type of object. I want a contact object. But in this database, when you say get first name, I want you to get the field F name. And over here, when you say get first name, I want you to get the field given name. And over here, I want you to get name first. Right? But it's the same object across each of them. We're almost definitely going to do that on a commercial level. I don't know if that will end up on the open side. Maybe. It's sort of up to Peter and our customers. So. But it ends up being a really good way to do it. We're actually looking at also at implementing a good portion of the stuff at schema.org. Is the schema.org stuff in tomorrow's?
Yes.
Yeah, so if you come to a World Without Applications, you'll hear a bit more about that. And some other, I think, some very creative ways in which we're looking to use graphs in the future. I hate to give away the punchline, but what if you had a search engine that was architected like this? Oh, let me find Acme Corp. No problem. Here's there's a string called Acme Corp, and it has an edge to everything and every single NSF you have anywhere in the entire company. What if you throw email in with that too? Oh, let's index all the messages and include those in the graph. Okay, no problem. Right? If you graphed email and you said, well, here's a message. It went out to these 10 people. All of those 10 people are also vertices in the graph, right? Because they're entries in your Domino directory. So they can be in the vertices in the graph as well. So you got your Domino directory over here. You have all your email over here. Here's one email message. It has 10 people's names on it. So you build edges. It went sent to this guy and to this guy. It was CC'd to these 3 people. It was BCC'd to these 2 people, and it was from this guy. Well, now if you do that with all the mail, then when you go to a person, what can you discover about their interactions throughout the company? Why doesn't Connections already have this? IBM needs to write us a big fat check.
Don't hold back. I hear they're hiring.
I'm not going to say I want to work there.
I just want the money.
Yeah. Other questions? Comments?
Rich text, I haven't heard that mentioned, so attachments and stuff, and this is...
Yeah, so that's not in the API yet.
Okay.
I definitely want to support it. The part of the challenge there becomes, you have rich text content, you want to put it into a JSON API, how do you represent that? You know, heavily escaped HTML, we can do it. You know, it's sort of scary looking, but it can happen.
Right.
Attachments, I haven't done yet, but that's kind of a high priority one. And it would come from some object which would have a set of there'd be sort of another property of the vertex object that would be an array that would give you URLs to all the file attachments that were in it. And maybe some extra stuff like types,
Yeah.
size.
At the moment, Google and Microsoft just pass the URL back, and then the client-side code has to get the image directly.
More questions? All right, maybe we'll just finish 10 minutes early and everybody can go get a drink.
All right.
All right. Thank you for coming. By the way, we're at the booth all day tomorrow if anybody wants to come by. And we have 2 more sessions tomorrow. Peter and I will be talking about a world without applications, and our new colleague, the FNG, Bob Cadry, and Keith Strickland will be talking about design matters. I hope you guys will come to them. I really want you to come especially to a world without applications because you're going to see lots of use cases for this stuff.